Alright guys, I'm going to do this side by side with the calculator because we're going to be using it a lot today. Today is February the 3rd, 2020. It's going to be page 14 in our binder. Alright, so today we're going to be finding the root of quadratics. Quadratic formula, if you remember, not quadratic formula, but quadratic functions. The parent function is y equals x squared. Anything that has an exponent of 2 would be considered a quadratic function. When you've seen it before is when we were doing trinomials, when we had ax squared plus bx plus c. That was a quadratic because we had our exponent. It was a quadratic function. We didn't really talk so much about it, called it more about trinomials. Anyways, today we're going to be graphing our quadratic equations and we're going to be finding the roots. The roots, all it really is where it crosses the x-axis. They're called x-intercepts, or you can also call them roots. Besides roots or x-intercept, they're also called solutions or zeros. Okay? If you have a function, a quadratic function, when you graph it, it makes a shape of a parabola. Remember, that's like a U shape? So if you graph it and you make a parabola, and the parabola crosses twice, no matter where it's at, if it crosses the x-axis twice, that would be two solutions, okay? Or two x-intercepts, or two zeros. If it only crosses or touches one time or one point, doesn't matter where, but one point on the x-axis, then it's only one solution, 1 0, one x-intercept. And if you graph it and it doesn't touch the x-axis at all, then it is no solutions, no x-intercepts, no zeros. For our notes, we're going to do a few examples, and we're going to be graphing it in the calculator. Let's go ahead and graph this one. You would go and open a graph in your calculator. Do not delete the equal sign. Remember, f of x is the same as y. So when it says here, number 1, y equals x squared, it's the same as f of x equals x squared. Plus 4x minus 5. Enter. All right, there's our parabola. Now, I can see that it's more on the left side, that my vertex is going to be down here somewhere, but I can't see it. If you want to use the calculator for it to find the vertex for you, the vertex, you would go to Menu, Analyze Graph, Analyze Conics, and Vertices. Then click on the table, the parabola. Again, if you want to do that as a shortcut, then I'm going to write it here, Menu 682, and then click on the parabola. If you hold down your mouse if you put it in the white place and then hold down your mouse, a little hand should come up. So let me try it. If you hold down the mouse, then move it, yeah, there you go, a little hand comes out, and if you move it up, you can actually see the pointer for the vertex. Well, the reason why I tell you to find the vertex is because that's the easiest place to start. If you didn't want to do that, well, I'll show you how to do it right now. All right, so I found the vertex. Go ahead and put that right in the middle in your table, -2, -9, and then fill out the rest of your table. So that's -2, -9. Then, I'm going to look for -1, 0, 1, -3, -4, and -5. That way I can fill out my whole table. To go to a table in the calculator, you're going to do Menu, Table, and split screen. Or if you just hit the Control and the letter T, it'll open and close it back up. So Control and the letter T will open your table, and then you can copy the values. But I'm on the positive side, so let me click up. I can see -1 is -8, 0 is -5, 1 is 0. -2 is -9, and I already knew that one. Let me keep going up. -3, -8, -4, -5, and 5, 0. Once you have your values from your table, go ahead and plot them on the graph. 1, 2, 3, 4, -5, 0 is here. -4, -5, 1, 2, 3, 4, and 5 would be down here. Negative 3, negative 8 would be here. Negative 2, negative 9 would be here. 1, negative 8. 0, negative 5, and 1, 0. The cool thing is that this has symmetry. You can see it here on your table. After the vertex, which is here, you can start seeing symmetry. That's negative 8, negative 8, negative 5, negative 5, 0, 0. You can see the symmetry. Go ahead and connect your points. Ugh. Wow, that was ugly. Let me try it again. Go ahead and connect your points to make your parabola. Okay, and it keeps going if you see the graph, but I'm only going to do the points that I have. So there is our graph. The last thing you need to do for your assignment is write down the solutions. Well, the solution is where it crosses the x-axis. Where does it cross the x-axis? All you got to do is look at your graph. It's crossing here and here at negative 5, 0, and 1, 0. Also, if you didn't have the graph, you didn't have the equation, you could find it here where y equals 0. That's your x-intercept. Yeah. All right. Now, if I was going to do this by hand, I would factor. Now, these are short enough for you to factor. You would look at the last number and then do the factors of 1. Well, there's only 1 and 1. And then pick the sign that would give you the middle term. The middle term is a negative 2. So they would both have to be negative, so they add to give me a negative 2. Well, here, it's negative 1, and they're exactly the same, x minus 1, x minus 1. So I only need to set 1 equal to 0, then solve for x. This is how you would do it by hand. Well, x equals 1 because 0 plus 1 is 1. Well, my x-intercept is going to be at 1. This is the only place where it touches the x-axis. So that means this is probably my vertex 2. And if I want to be sure, well, let's go ahead and plot it. So let's verify. And let me go ahead and open a graph. I'm going to plug in x squared minus 2x plus 1. Oh, there it goes. It is also our vertex. And since there's only 1, right, because x minus 1 and x minus 1 will still give me, if I solve for x, doesn't matter which one, will give me a positive 1. So that's our vertex, 1, 0, and it's also our solution. So in this case, it's our vertex and our x-intercept or our solution. Okay. Here they were over here when y was 0, and y is still 0 here. Then, in order for me to do this by hand, if I didn't have a graphing calculator, I would then plug in values for x. I would plug in 2, 3, 4 here. So I would put 2 squared minus 2 parentheses x. Well, not x, right? Because we're substituting in place of x. We're putting a 2 plus 1. So I substitute in 2 because I'm here in the next value for x. Then we would do the math. That's 4 minus 4 plus 1. 4 minus 4 is 0, plus 1 is 1. So this is what? X equals 1 there. I mean, y equals 1. Then I would plug in a 3. Then I would plug in a 4. And then I would go backwards and plug in a negative, not a negative 1, a 0 first, then a negative 1, then a negative 2, and all my outputs would be my y column. Well, if we go control table, control T for table, I can just get the values there. 2 will give me 1, 3, 4, 4, 9. And then 0 will give me 1, then 4, then 9. So I guess you only have to do a couple of them because then you start seeing the symmetry, right? All right, plot them. So that's 0, 1, 2, 1, negative 1, negative 4, 3, 4, and then 2, 9. Okay. All right, backside.